Hi, good evening. Welcome back to our today's presentation on time response analysis specifications of second order system. So, in our last presentations, we have seen various time domain specifications of a second order system. Okay, today we'll see the lecture number 32. Lecture number 32. So in today's presentation, we will see the another time domain specification, that is peak overshoot or maximum peak overshoot. So for the time domain response of a second order system, we have seen various parameters like delay time, and then the second one is rise time, means it is delay time, T suffix D we have seen, it is T suffix R, and then the third one, the peak time, that is T suffix P, and the fourth one is maximum peak overshoot. Maximum peak overshoot, normally it is calculated in terms of percentage and it is denoted by capital M suffix P. And then the fifth one is settling time, that is T suffix S. These are the various important time domain specifications of a second order system, out of which in our last presentations we have seen the first one, delay time we have seen, and then rise time also we have seen, and peak time also we have seen. In today's presentation we will see about the peak overshoot, or otherwise the maximum peak overshoot. So basically we are seeing the mathematical definition of these parameters first, and later on we will see various problems on these specifications. Okay, we'll see today the maximum peak overshoot, and it is denoted by the letter capital M suffix P, and it is calculated in terms of percentage. Okay, maximum peak overshoot. So by the way, I will represent, or I will show you one more time about how the time domain response looks like. In our previous presentations we have seen, but for your time being I will show you. So for the second order control system, the time domain response will be like this. Like this we have seen. Okay, so this is basically the delay time. This is TD, normally it is 0.5. This is time versus, this is the time, actually this is already time in terms of seconds. This is time axis versus y axis is C of t. So this is our response, C of t, and this is the response basically, if you see. So we know that what is TD, delay time. Delay time is nothing but the time required for this response to reach 50% of its final value. 50% is nothing but 50 by 100, 1 by 2, that is 0.5. Like that's why, so TD is up to 0.5. And similarly, exactly at this one, this there is another time you can define. This is the TR, means rise time. So TR is the time, means rise time. Rise time is the time required for this waveform or the response to reach 100% of its final value. Means if it reaches the value of 1, that means that has reached to its maximum, I mean 100 value. And then this is the peak basically, and here also at peak you can define another time parameter or specification TP. So that means, so if you draw like this, so this is the time required for the waveform to reach the peak value of, okay, of its peak value. That is the TP, peak time. And then what is the settling time? Settling time is nothing but that is the time required for the waveform to settle in the tolerance band. So if you see this is the maximum peak. This is the peak is decreasing here, little bit decreasing, little bit further, and it settles near, exactly nearer to the 1, the value of 1. There is a tolerance band basically, plus or minus 2%. Okay, so there is a tolerance band. So in this, within this tolerance band, the waveform will be settled. So the maximum, the peak will be decreased and it will be settled basically. So that period is called from starting value to and the time at which the waveform settles. So that time period is called as settling time, TS. Okay, and then in today's specification, which we are going to see, that is the maximum peak overshoot. That is nothing but the maximum peak overshoot is nothing but that is the ratio of the maximum peak value to the value of this one. This is the peak value basically. Okay, and from here up to 1, if you take the magnitude value 1, from 1 if you calculate from 1 the here to peak value, the difference between these two is called as peak overshoot. Okay, if you take the gap, means from this 1 line you are showing, no, from here to the maximum value, so this difference calculated in terms of percentage, that is called as peak overshoot. And there is a mathematical definition for this, MP, percentage M suffix P. I will give you the definition. I will show you that. Okay, so that is defined as percentage of M suffix P is equal to, normally, okay, it is C of T suffix P minus C infinite by C infinite into 100. That is its definition actually. What is C? C of T is nothing but your response. Okay, C of T is nothing but, obviously always remember, C of T is the response of the system. It is response or output, response of the system for the given system. So what is TP? So here for the time T, we are considering C of T at T is equal to TP, means peak time. At peak time, at time TP, what is the value of that response? That is what C of TP. Okay, and what is the C of infinite? Infinite is nothing but the final steady state value. C of infinite is nothing but final steady state value. That is final value actually. That's why that is also called as final steady state value. Final steady state value. So if you know the value of these two, okay, C of TP and the value of C of infinite, then if you substitute those values in this formula, this is the formula for that. If you substitute those values in which, we will get the expression for percentage of MP, that is peak overshoot. So what is C of TP and what is C of infinite? First we calculate what is C of T, and before that, what is C of T first of all? you write the expression for C of t. What is C of t? C of t is the response of a second order system for unit step input. Okay, so we already discussed in our previous presentations, and if you can recall in our previous presentation, so the response of a second order system for a unit step input, the C of t can be given as C of t is equal to 1 minus e power minus zeta pi by under square root of 1 minus zeta square into zeta pi, okay, into sine omega d t plus theta. This is what? Okay, C of t is equal to 1 minus e power minus zeta pi by square root of 1 minus zeta square by sine omega dt into t. Okay. Okay. Then so substitute at t is equal to substitute for t is equal to infinite, because at C of infinite value we are seeing C of infinity value we are seeing. So if you substitute that, so here you can write, is it zeta, it is omega n into t normally, minus zeta times omega n into t by square root of 1 minus zeta square sine of omega dt plus t. So if you substitute for t equal to infinite, then substitute wherever t is there, substitute infinite, then this becomes what? So C of t becomes C of infinite, it is 1 minus e power minus zeta omega n in t place substitute infinite by square root of 1 minus zeta square into sine of omega d infinite plus theta. Further, if you see that e power minus zeta omega n into infinite, so means infinite into something infinite, infinite minus total is minus infinite, e power minus infinite is 0. So e power minus infinite value is 0. E power infinity is 0. So means that this value becomes 0. So 0 by something is 0. 0 into something is 0. Therefore 1 minus 0 is totally, your value becomes here C of infinite value becomes 1. So your final steady state value becomes 1. Okay. That is what? C of infinite value is 1. Then calculate what is C of Tp. So remember that C of infinite final steady state value is 1. Okay. And now substitute T is equal to Tp. In next step, substitute here C of Tp, T suffix P. So this is equal to 1 minus e power minus zeta omega n, what is T? Tp, okay, by under square root of 1 minus zeta square into sine of omega d, it is Tp plus theta. Clear? And again, what we know? It is Tp is the peak time basically. Tp is peak time. So we know that what we know actually, Tp peak time is equal to pi by omega d. This we have seen in our previous presentations. So we know the formula for Tp is equal to pi by omega d. So substitute the Tp value as pi by omega d. Okay. Then if you substitute that, then you will get C of Tp is equal to, it is 1 minus e power minus zeta omega n by pi by omega d under square root of it is 1 minus zeta square into sine of omega d pi by omega d plus theta. So this omega d gets cancelled. Clear? So what you will get the next step? So the next step will be looks like this. I will write the next step for you here. I will erase this. So C of Tp is equal to, let us say here, 1 minus e power minus zeta, it is omega n pi by omega d. Pi, again omega d, what is omega d? Omega d is nothing but omega n into square root of 1 minus zeta square, okay, by square root of 1 minus zeta square. This is sine of omega d cancelled out, it is pi plus theta. Okay, here we know that omega d, from here omega d is equal to omega n into square root of 1 minus zeta square. This is we already seen in previous presentations. This is damped natural frequency, this is the natural frequency, this is the relation between these two, damped natural frequency to, this is the damped natural frequency, this is the natural frequency. This is the very important relation between these two. Therefore, if you substitute omega d is equal to omega n, that's what I have written here. So again here omega n and omega n will be cancelled out. These will be cancelled out. Then again if you see sine of pi plus theta. So from the trigonometric definition, sine of 180 plus theta is nothing but, what is sine of, here sine of pi plus theta, pi is nothing but your 180, means sine 180 plus theta is minus sine theta actually. Okay, sine of pi plus theta is equal to minus sine theta. Therefore sine of pi plus theta comes minus sine theta. So minus of sine theta. So minus, and this minus will be multiplied, minus into minus plus, then plus sine theta you can write here. Okay, then the next step, how it will look like. So here this is equal to 1 minus, means minus sine of pi plus theta is minus sine theta, that minus into this minus is plus, okay, e power minus zeta, omega n already cancelled out, zeta pi by square root of 1 minus zeta square, here sine theta. Clear? This is what your C of Tp. And here there is a small, if you construct a right angle triangle between the parameter zeta and 1 minus zeta square, if you construct a right angle triangle here, okay, let us take it as zeta and let us consider this one as square root of 1 minus zeta square, this one. Consider the zeta on the this axis and 1 minus zeta square on this, and you applying your this Pythagoras theorem, then obviously zeta square plus zeta square is equal to, so this will satisfy, then obviously we will get the value of 1 for this. Okay, then from this triangle you can define what is sine theta value from here. So from here you can get sine theta is equal to opposite side by 1 minus zeta square by this one. Okay, it is 1 hypotenuse. So it is 1 minus zeta square by 1, it is nothing but square root of 1 minus zeta square. Therefore your sine theta is equal to 1 minus zeta square from this triangle. Then substitute that value here, then you will get in the next expression, what is your next expression? 1 plus e power minus zeta pi by under square root of 1 minus zeta square into square root of 1 minus zeta square. Is it not? Your sine theta is equal to 1 minus zeta square by 1. So these two value will be cancelled out. Then what remains, you know? It is 1 plus e power minus zeta pi. Is it not? This I have forgot, I think. This one, this is already there, no? Square root of e power minus zeta square by. This is already there. This you should not forget, 1 minus zeta square. This also in exponential it is there and denominator part is there. So this denominator part will be cancelled out. This one will be cancelled out. But e power minus zeta by 1 minus zeta square will be there. Clear? This is what your C of Tp. This is what your C of Tp. Now substitute this one into the initial definition. So in initial definition, what we have seen for maximum peak overshoot? What you have seen for maximum overshoot? So it is percentage of peak overshoot is equal to, it is C of Tp minus C of infinite by C of infinite into 100. What is C of Tp? This is what C of Tp. 1 plus e power minus zeta pi by under square root of 1 minus zeta square. That is what Tp minus C of infinite. What is C of infinite value is 1 now? By 1 into 100. Clear? So from this implies 1 minus 1 get cancelled out, then it is by 1. Obviously it is nothing but e power minus zeta pi by square root of 1 minus zeta square into 100. That is what your percentage of MP. Clear? This is the formula. This is your peak overshoot formula. So this is the mathematical expression for this peak overshoot. So I think you have enjoyed it. I will close this presentation here and we will continue in our subsequent presentations. Okay, thank you.